To make sure we are starting on the same page with regard to terminology, we'll use the terms accident and mishap interchangeably. The dictionary definition of an accident makes the event seem like a random or chance event. Erickson states that accidents do not just happen, that they are the result of hazards, which are predictable when properly analyzed. So the layman's idea of an accident is a chance or random event, while the engineer's idea of an accident is it's a predictable or preventable occurrence. I think reality really lies in between, probably more on the side of preventable, but not 100% because there is still the likelihood and chance factor. The main point, though, is that we have control over the level of risk, and we can identify and mitigate hazards to reduce our chances of being involved in a mishap. So let's talk about the relationship between the hazard and a mishap. There's a timeline here. Hazards can be well known, or they can lie dormant for years. Techniques that we will learn in this class will help us be able to root out and identify hazards, even those secret, dormant hazards that are waiting quietly in the system. A hazard requires a triggering event in order to be actuated. Our scenario of the mountain last week illustrated that. The mountain lies there minding its own business until a triggering event occurs to cause an accident. It could be fog or weather limiting visibility, the need for an aircraft to be low and close to the mountains, pilot unfamiliarity with terrain. Any, several, or all of those triggering events can result in a mishap. But you have a hazard, you have a triggering event that occurs, and that triggering event needs to happen before the mishap will occur. The rest of the timeline is still important. It is the accident sequence and generally happens within a very short amount of time, few seconds if even that long. As the accident unfolds, how much damage occurs to people and property, or how crashworthy and survivable is the system. Here's another hazard mishap scenario. I'm recording this video near Christmas time. We have candles burning in the house that smell pretty and give a warm atmosphere in the house. I also have 4 kids who are all under 9 years old. The youngest is 4. That's not him, but it's an example. The hazard is an open flame of the lighted candle. There's the hazard. The mishap would be burning down the house. However, the flame contained in the candle will not burn down the house. The flame as it's contained in the candle will not burn down the house. However, the 4-year-old grabbing a hold of the candle on accident or throwing her ball through the house and knocking it over, that's sure an initiating event. As such, while we enjoy the candles, we could either eliminate the hazard and not use them until the kids grow, or keep the candle out of reach of the children. We choose to do the second option, which does not eliminate the possibility of a mishap. It does not eliminate the likelihood, but it reduces the chances greatly. Erickson says that if we can eliminate the hazard, we can prevent a mishap. And that sounds good, but not always the case. Sometimes we like to have candles burning. Sometimes we need to use propane, fuel, fly in mountainous terrain, etc. Sometimes we need to do hazardous things. We see, though, that a mishap occurs when a hazard is actuated. And there's a direct link between the hazard and the accident, or triggering event. We will learn more about that in the next video when we talk about the anatomy of a hazard.